In this video, we will discuss modes of bond cleavage and various factors which affect modes of bond cleavage. For more videos, you can visit us at educationstudio.in. Bond cleavage. Bond cleavage is of two types. One is homolytic bond cleavage. Homolytic cleavage is that in which both the electrons of the bond are distributed equally. Each atom will take one electron from the bond. There will be no new charges that will be generated. Let us see. This is before bond cleavage. When A-B bond will undergo cleavage, both A and B atom will take one electron each from this bond in this way. So therefore, in this cleavage, no new charge will be generated because each atom will take its own electron which they had contributed during the formation of that covalent bond. So after homolytic bond cleavage, we will be getting free radicals. Another bond cleavage is heterolytic bond cleavage. In this, both the electrons of the bond that will be broken are taken by one atom only. New positive and negative charges will be generated. Negative charge will develop on that atom which will take both the electrons, while positive charge will be generated on the other atom. This is AB molecule. Let us assume B will take both the electrons when bond will be broken. So in this way, both electrons are moving on to B. So therefore, B will become negatively charged and A will become positive charged. This is after heterolytic bond cleavage. Negative charge will develop on that atom which has taken both the electrons. Let us now study factors which will affect modes of bond cleavage. One factor is electronegativity difference. Higher the difference of electronegativity of the concerned atoms, more will be chances of heterolytic cleavage. This is HBr molecule. Br molecule is more electronegative. So there is quite large difference between the electronegativity of H and Br. So therefore heterolytic bond cleavage is more likely. In this way, both the electrons will go to more electronegative Br atom that will become negatively charged. Hydrogen will become positively charged. Negative charge developed at the atom getting both electrons. Now if we see another molecule Br2, there is no difference in electronegativity. So homolytic bond cleavage is more likely in this way. There will be no new charge development. Another factor is type of solvent used. Now we may use polar solvent, we may use non-polar solvent. So if we are using polar solvent, we can further say more the polarity of the solvent used, more will be chances of heterolytic cleavage. This is because more polar solvents will stabilize ions formed by heterolytic cleavage more readily. Let us see Br2 molecule. Although there is no difference in electronegativity, but if we take a highly polar solvent like water, in water there will be chances of heterolytic cleavage. So any one Br atom will take both the electrons during the homolytic cleavage, heterolytic cleavage. Let us say in this way. So the atom which has taken both the electrons, that will become negative, other atom will become positive. This Br minus negative ion is more attracted by water, so it will be stabilized. Br positive will be stabilized by water because water is polar. Now if we take Br2 molecule in gaseous state, there is no difference in electronegativity and we have not used any polar solvent. So therefore, the chances of homolytic cleavage will be more and the bond will be broken in this way. Mode of bond cleavage depend on yet another factor, which is type of reagent used for the bond cleavage. Electrophilic and nucleophilic reagents can never do homolytic cleavage because they cannot form a bond with free radicals. Therefore, electrophile and nucleophile can do only heterolytic bond cleavage. Let us see how electrophile will do heterolytic cleavage. This is our Cl molecule in which there is delta positive charge on alkyl part and delta negative charge on Cl. So when any electrophile is added, electrophile will approach negatively charged chlorine, and heterolytic cleavage will occur in such a way that both the electrons will be taken up by chlorine and those electrons will be used to form bond with electrophile. In this way. And let us see how that bond cleavage of RCl bond and bond formation of electrophile with Cl will occur in a step. So R will become positively charged and heterolytic cleavage will occur. Let us now see how nucleophile will do heterolytic cleavage. This is RCl molecule, delta positive charge on Cl, delta positive charge on alkyl part, delta negative charge on Cl. This is nucleophile. This is positively charged, delta positively charged alkyl part. Nucleophile will approach the delta positively charged carbon atom of alkyl part. Therefore, nucleophile will combine with it and both the electrons will be taken by Cl atom. In this way. So this is how the cleavage will take place. Electrons of the nucleophile will form bond with alkyl part and electrons of RCl bond will be taken by Cl. Free radical reagents can never do heterolytic cleavage because they cannot form a bond with R plus or R minus. Therefore, free radical reagents can do only homolytic bond cleavage. Let us see AB molecule and a radical Z. Now, Z can either combine with B atom in this way. So, homolytic cleavage of AB will take place, B will combine with Z, A will get the unpaired electron. However, that free radical can also combine with A atom and will do homolytic cleavage in this way. So therefore we can understand that during homolytic cleavage radical reagent can combine with either atom A or atom B. Fourth factor which can affect the mode of bond cleavage is radiation energy. Now let us understand that homolytic bond cleavage requires higher energy than heterolytic bond cleavage. This is because a pure covalent bond is much stronger than ionic bond. So therefore homolytic cleavage, which is a perfect cleavage of pure covalent bond, will require higher energy. And therefore this type of cleavage will require much higher temperature. However, if energy is provided in the form of radiations which travel in the form of packet, those packets of energy are taken by only few molecules. Each molecule will get a large amount of energy and this will favor homolytic cleavage. This is how a packet of energy in the form of light is coming. That packet will be absorbed by AB molecule and the cleavage will occur in homolytic manner in this way. However, if two adjacent atoms having lone pairs belong to second period, we have already discussed the repulsion between lone pairs dominates to weaken the bond, making homolytic cleavage easier. Other free radicals are generated by heating peroxides which dissociate easily to generate RO radicals, these RO radicals react further to generate other radicals. This is because both the oxygen atoms are having lone pair. Oxygen atom belongs to second period. So OO bond is relatively a weaker bond. Its homolytic cleavage is easy and can occur under normal conditions. These RO dot will be then helpful and will do homolytic cleavage of other bonds which will be used in the reactions.